Hello, welcome back to our channel. Today we are going to discuss about short answer questions from the atoms. Many people are asking, please describe that short answers from the atoms. So it is very important for both AP and Telangana State Intermediate Board. So we can go through these answers. Even the first short answer question is what is impact parameter, then what is that second point is what is angle of scattering and what is the relation between them. If we want to know about this compulsory, we have to go through the Rutherford's alpha scattering experiment. The first person who given that at the center of the atom nucleus is there, that is having the positive charge, and how it is possible, look here. See, suppose this is the atom, center of the atom is having the nucleus, this is the positive charge. When alpha particles are coming towards this, what happens? This is positive and alpha particles also positive. That's why these are retraced back. Here angle of scattering is how much? Theta equals to pi degrees. Then suppose some more distance we are taking. Then these are deflecting. Here theta is less than 90 degrees. Okay. Here first thing, what is impact parameter? So in the alpha scattering experiment, the perpendicular distance between center of the nucleus, these alpha particles, to this one is called the impact parameter. It is represented by B, and here angle of scattering is the theta. So based on the situation, if it is exactly at center elastic collision, angle of scattering is pi. Then what happens? Less than 90 degrees. When the impact parameter is increasing, this angle of scattering is decreasing. So this is the relation between impact parameter and angle of scattering. Then our next question is very important. They are asking, this is as a short answer as usual. Long answer, many expressions are there, listen carefully. But the question is, see, derive an expression for the potential and kinetic energies of an electron in an or any orbit of hydrogen atom according to the Bohr's atomic model. So here, look here, we should derive the what is potential energy, what is the kinetic energy, what is the kinetic energy. Look, already you know that from the Rutherford's alpha scattering, then Bohr came and he said that yes, atom is having the spherical shape, center of the atom is having the one positive content, that is called the nucleus. Around the nucleus, electrons are revolving around this. Then he focused on that, what is the potential energy of that one and what is the kinetic energy of that one in nth orbit. So for this, first of all, the basic thing is, look here, this is the nucleus. Around the nucleus, electrons are having the revolving around the nucleus in circular orbits. See, these are the electrons. This is the nucleus. So whenever the body is having the circular motion, means it is having the centripetal force. But here centripetal force is provided by which force? Electric force. Why? Nucleus is having the positive charge, electrons are having the negative charge. So we can write here centripetal force equals to electric force. Don't confuse centripetal force, mv square by r. R is the radius of this one. Electric force is the 1 by 4 pi epsilon naught. Q1 Q2 by r square. Here Q1 is charge of the electron and Q2 is what? How many number of electrons are there? Ze by r square. So which is here mv square, r cancel. Mv square equals to 1 by 4 pi epsilon naught Ze square by r. This is we are taking equation number 1. Then we can go through the Bohr's second postulate. According to Bohr's second postulate, so these are having the circular motion and this angular momentum mvr equals to, from Bohr's second postulate, we can take it mvr equals to nh by 2 pi. N is the which number of the orbit and h is the Planck's constant and v is the velocity of electrons and r is the radius of this one. So from this, what is expression for v? V equals to nh by 2 pi into mr. This is equation 2. We are substituting in equation 1. Then what we are getting? Look here. So mv square m into v square equals to 1 by 4 pi epsilon naught. First of all, instead of v, what we are taking here only directly we should write it. So n square h square by 4 pi square m square r square equals to RHS side. Already we know that this is 1 by 4 pi epsilon naught z e square by r. After simplification, we are getting the expression for r, radius of the nth orbit. So what we are getting after simplification, look here, this r is cancelled. Here r equals to, we are sending that side, and one mass, another mass is cancelled. 4 cancelled. This one is cancelled. So r equals to, we are getting n square h square epsilon naught divided by, what we are having here, 4 is cancelled, pi, 1 m is here, and here r we are sending this side, pi m z e square. This is the radius of the nth orbit. This is the radius of the nth orbit, that is h square n square epsilon naught by pi e square m into z. If you want to take, this is the hydrogen, means instead of z we can take it, especially they mentioned in our question, that is the Bohr's hydrogen atom, means we can take it z equals to 1. Then r equals to n square h square epsilon naught by pi m e square. With the help of this only we can able to derive the expression for what is potential energy and what is the kinetic energy. First we can go through the expression for the kinetic energy. Kinetic energy, what is the formula? Half mv square. Half mv square. But already you know that here mv square is the 1 by 4 pi epsilon naught z e square by r. So 1 by 2 into, instead of mv square, what we are taking? 1 by 4 pi epsilon naught z e square. But the thing is, already you know that, or instead of z we are taking 1 only. So e square by, instead of r we are taking n square h square epsilon naught by pi m e square. Pi m e square. So after simplification we are getting the expression for kinetic energy is, see, this by cancel. 1 by, this is how much? 8 epsilon naught square n square h square. This is the denominator. And when it will reverse, what we are getting numerator? See, m e to the power of 4. This is the expression for kinetic energy. So Ke equals to m e to the power of 4 by 8 epsilon naught square n square h square. This is the kinetic energy. Like that, how to derive the expression for potential energy? Potential energy formula is, you know that, see, 1 by 4 pi epsilon naught Q1 Q2 by R. Q1 is the charge of that electron, Q2 is the charge of that nucleus, and the remaining are the constants. Q1 Q2 by R. R is the radius of the nth orbit. So potential energy equals to minus 1 by 4 pi epsilon naught. Why we are taking minus? It is representing the attractive force. It is representing the attractive force. See, Q1 Q2 we are taking E square only, divided by, instead of R we are taking n square h square epsilon naught by pi m E square. After simplification we can get it, potential energy equals to minus m e to the power of 4 by 4 epsilon naught square n square h square. So when we are observing this kinetic energy and potential energy, you can get it. This is plus and this is the minus. Here minus is representing the attraction. Like that, when you want to attach this one long answer from this chapter also, total energy means we can add potential energy plus kinetic energy. You can get that expression also. Don't confuse here. Come back to this answer. First thing, we should derive the potential energy and kinetic energy of Bohr's hydrogen atom. For this, you know that electrons are revolving around the nucleus in circular orbit. Circular orbit means it is having the centripetal force, and you know that centripetal force is not the basic force, it is provided by which force here? Electric force. So Fc equals to electric force, we are writing the expression, and you are getting mv square equals to how much? Then we can go through the, from Bohr's second postulate, angular momentum is equals to nh by 2 pi, and we are getting the expression for v. When we know the v, substitute in this expression, you are getting the radius of the nth orbit, r equals to n square h square epsilon naught by pi m e square. So till here we didn't find out the kinetic energy, we didn't find out the potential energy, and you know only the expression of radius of the nth orbit. Then how to derive the expression for kinetic energy? Ke equals to half mv square. So 1 by 2 into, instead of mv square, don't confuse, instead of mv square we are taking this part, then directly I have substituted instead of r n square h square epsilon naught by this one. So after this we are getting the expression for this kinetic energy. Then potential energy, we can go through the electric potential energy 1 by 4 pi epsilon naught q1 q2 by r. So instead of q1, charge of the electron, and this is z square by, after this we are getting potential energy equals to minus m e to the power of 4 by 4 epsilon naught square n square h square. Third short answer questions is, explain the limitations of Bohr's theory. You know that Bohr's, what he explained, electrons are revolving around the nucleus, and these are not losing and not gaining the electrons when these are in the orbits. But he didn't explain that why these are not radiating energy and why these are not having the different intensities. And when the atom, any atom is having the more than one electron, he failed to explain that this Bohr's theory, and these are the limitations of the Bohr's theory. Then our fourth short answer question is, what is the closest distance of approach? And one more time they are asking, what is the impact parameter? See, it's very interesting. You know that from the Rutherford's alpha scattering experiment. See, this is the nucleus. When alpha particles are coming here, alpha is having the positive charge and nucleus is having the positive charge. Repulsion means here some gap we should observe. This is the closest distance of approach we are taking. This is the d. So when the alpha particles are moving from here to here, then what happens? It is having the kinetic energy. When it will stop because of that repulsion, it is having the potential energy. So we can take it here. Kinetic energy equals to potential energy. So kinetic energy equals to, instead of potential energy, we are taking 1 by 4 pi epsilon naught z e square. So this alpha particle, any nucleus, you can take it Ze. This alpha particles is, you are taking 2 electrons are having, that's why q1 q2 by the distance of closest approach is the d. So after deriving this d is the closest distance of approach, we are writing 1 by 4 pi epsilon naught 2 z e square by kinetic energy. This is the closest distance of approach. Don't confuse here. Here kinetic energy. So when the alpha particle is moving, having the kinetic energy, because of the repulsion, it becomes to potential energy. That's why this is the electrostatic potential energy and this is the kinetic energy. After writing that expression, d is representing the closest distance of approach. Then already I said what is the impact parameter in first short answer. Anyway, you can watch here. See, when alpha particles are coming, these are deviating like this. So this perpendicular distance is called the impact parameter. This is our fourth short answer question. Then fifth short answer question, experimentally also I have derived in our physics in our daily life. What he said, he explained, he has taken one watermelon. He said that seeds are representing the electrons and remaining is representing the positive charge, that is a J.J. Thomson. But he didn't explain the spectral lines. So that is the J.J. Thomson atomic model. Then very simple answer, already you know in chemistry in first year also you should learn this one. Then our sixth short answer question is, describe the Rutherford atomic model and what are the drawbacks of this model. You know that this only Rutherford alpha scattering. Look here, sixth one. See, this is the nucleus. When alpha particles are striking this one, these are scattering. Theta is less than 90 degrees, theta equals to pi degrees, and sometimes this is like theta is greater than 90 degrees. These are deviating. When he did this experiment with the help of the gold foil, and he discovered that atom is having the nucleus. The total mass of the atom is concentrated at the center of the atom. That part is called the nucleus. And he said electrons are revolving around it in circular orbit. So this is very good information, but the drawbacks are why these electrons are revolving around this, and why these are having the circular orbit. If they are having the rotating in circular orbits, these are radiating the energy, and that one he didn't able to explain that one. These are the drawbacks of the Rutherford's alpha scattering experiment. Then our the difference between excitation potential energy and ionization potential energy. In that only meaning is that excitation potential energy means the electron is jumping from one orbit to the another orbit. It requires the energy. So the energy required to jump the electron from one orbit to another orbit is called what? Excitation potential energy. Like that, what is the ionization potential energy? See, we want to remove the electron from the atom, we require some energy. So the minimum energy required to remove the electron from the atom, that is called the ionization potential energy. Then our eighth short answer, difference between excitation potential energy and ionization potential energy. In that only meaning is that excitation potential energy means the electron is jumping from one orbit to the another orbit. It requires the energy. So the energy required to jump the electron from one orbit to another orbit is called what? Excitation potential energy. Like that, what is the ionization potential energy? See, we want to remove the electron from the atom, we require some energy. So the minimum energy required to remove the electron from the atom, that is called the ionization potential energy. Then our eighth short answer question is, see, very short answer is explain the spectral series. Explain different types of spectral series of hydrogen atom. You know that hydrogen atom is having the 5 spectral series. First one is a Lyman series, Bohr series, Paschen series, bracket series, and P-Fund series. When we can go through the Lyman series, the electron is jumping from higher energy level to the first orbit, that is represented by N1. So here N1 equals to 1 and N2 equals to 2, 3, 4, like that. Then when you can go through the Bohr series, already you know very well about this answer in first year chemistry. So first one is the Bohr series. Here N1 equals to 2 and the electron is jumping from the higher energy orbit to the N2 equals to 3, 4, 5, but N1 equals to 2. Like that, Paschen series is N1 equals to 3 and N2 equals to 4, 5, 6. This is the bracket series, and last one is the P-Fund series. It's very easy for you. But in this chapter, the very important short answer, 90% expected for final exams is this short answer. See, write a short note on de Broglie explanation. See, 2 scientist names are here. De Broglie explanation of Bohr's second postulate of quantization. See, Bohr has given second postulation, and according to that, what is that? MVR equals to NH by 2 pi. So how you are deriving this one? It was explained by the de Broglie. Look here, de Broglie explanation is, see, when the electron is revolving around the nucleus, this is the nucleus and these are the electrons. So in this stationary orbit, electron is not stationary. In this stationary orbit, electron, whenever it is moving, it is having the particle nature as usual, wave nature, and it forms the stationary wave like this. It is forming the stationary wave. Means 2 progressive waves are traveling in opposite direction. These are forming the stationary wave. So circumference of this circular motion is 2 pi Rn equals to n lambda. Then lambda equals to 2 pi Rn by n. But from the de Broglie hypothesis, You know that relation between the wavelength and wave velocity is lambda equals to h by mv. So instead of lambda we are writing 2 pi rn by n. Rn is the nth orbit, don't confuse here, equals to h by mv. Now you do the cross multiplication. mv rn is the LHS side, h by 2 pi, h by nh by 2 pi is the RHS side. So this is the Bohr's second postulate, mv r equals to nh by 2 pi. Thank you everyone. Please subscribe my channel.